7, Postfire Mapping and Analysis. Here is your mission. It is the end of the fire season at the Grand Canyon National Park, and you are told that next season you will be helping the Burned Area Emergency Response Teams, or BEAR teams, to create Burned Area Reflectance Classification Maps, or BARC maps, for areas in the southwest region that burned with high severities and could potentially have consequences on the watershed and other natural resources. In preparation, you have been given access to some training to 1. Learn how to acquire Landsat imagery and convert that into severity maps, known as DNBR, and 2. Learn how to create BARC maps with Landsat imagery and ground truth points. We will begin this exercise by adding data to a blank ArcMap. So you've already downloaded the data and unzipped it from its folder. And I'm going to add here and navigate to my Lesson 7 folder and into my DNBR data. And I'm going to be adding 2 different files. I'm going to be adding these files that begin with the letter P. And notice there are 2 different numbers here. So we've got a 700 and 800. So we're adding both of these. Hold Control and add. These images are Landsat Images, and they were downloaded from a website where you can access all different views of the Landsat imagery based on location. So this document is available for you on BBLearn, and you can look into how to order Landsat imagery for various areas at various times of the year. Notice the view here. So the sensor goes over, it creates this swath, and you can see the view of the image at somewhat of an angle. You select your image and your specifications, and then you have your download file. Now when you download it, that would be in the raw data format. And the raw data format is not quite ready for computation. And so there's another process that goes on that we won't be going through today that goes through and radiometrically corrects the images. So what that means is it takes the digital numbers that come from the satellite and it converts those to reflectance values. So the satellite observes numbers and we need them in reflectance values. So the burned area is easier to see if these are displayed differently. Right now they're displayed in what we would visually see if we were to look at these areas. But we want to be able to see it with different colors displayed. So we're going to go to our first image here and go to Properties. And Symbology. And notice I have a couple of different options here. So right now the default is layer 1, layer 2, layer 3, but I actually want to change this to layer 6, layer 4, and layer 2. One thing to note is layer 6 is actually band 7, so in the presentation you may have noticed that we were talking a lot about band 4 and band 7, and so layer 6 is that band 7. We display 6 of them, so it gets the value 6. And click OK, or Apply. Okay. And so you can see that we have this change of value, so we'll go ahead and do this for our other image as well. Six, 4, and 2. So now we have what's called a false color image. The next step we're going to do is to compute DNBR. To do that, we'll first need to calculate NBR pre-fire and NBR post-fire. So we're going to add some individual bands. So these are the compilation of all the bands added in this image, and so we're going to add a couple other things. So we'll go to plus. Now here we're actually going to open up this grid file. So we're going to double click on this 700 layer, and notice you've got all these different layers. So before we had them displayed all together, and now we're going to add them individually so that we can do some calculations. So we're going to add band 4 and band 6, since band 6 is represented by 7. And then we'll go to the August file. So this is the 8, and we'll add those 2 bands as well. So 7 stands for July, 8 stands for August. So we've got pre-fire in July, post-fire in August. And we're going to go to our raster calculator. So in Toolbox, we'll go to Spatial Analyst Tools and Map Algebra, Raster Calculator. So now I'm going to make my equation. So I'm going to use the keypads in this calculator here as much as possible. So I'm going to add a parenthesis, double click on July's layer 4, and then then subtract, and minus band 7 or layer 6, close my parentheses, and then divide parenthesis by July layer 4 plus layer 6, close parentheses. So this is the equation that we learned in the presentation as calculating NBR. So we will now figure out where we want to put this raster. And in my lesson 7 folder, I'm going to make, in my DNBR folder, I'm going to make a new folder here for outputs. Click Save. Oops. There we go. And I'm going to name this NBR Post, pre. Click Save and OK. And I got an error message. Let's see what happened. And my background server threw an exception, so I'm going to go and just try this again. Sometimes that's all it needs. So now I've actually restarted ARC, and I will try this again. And I'll check my progress in geoprocessing. Looks like it's working on it. So that was successful. That took several minutes for me to run. And now I'll go and do that same calculation with the Postfire images. Got my parenthesis. There we go. NBR post. And for whatever reason, that one finished up a lot sooner. So now I've got my NBR pre and NBR post. And there's post, there's pre. Let me turn these off, so I'm going to press Control, make them all small. Then I'll just turn pre on and post. So you can see the footprint of this fire now, before and after the fire. So now back to our raster calculator, we're going to go to our DNBR calculation. So we're going to take 1,000 This is just a scale thing so that our values are whole integers instead of decimals. And times parenthesis NBR pre minus NBR post. So what we're doing is we're trying to see the change from pre-fire to post-fire. Click OK. Great, so now we can see this really distinct area of change pre to post fire. If you were not looking at DNBR, you might be a little bit confused by this patch here, but if you notice, that exists before the fire and after the fire. It might be some kind of thinning project or something. I'm not sure exactly what that is. So, but here's our DNBR, and now we're going to classify this so that it looks more like a bark map. So I'm going to go over here and go to Properties, and instead of stretched, I want it to be classified. And click Yes for computing a histogram. And so looking at the table from your lab, we're going to see how many classifications we need this to have. So we've got 1, 2, 3, 4, 5, 6, 7 classes. So I'm going to go to Classify here and change this to 7. And these breakpoints are going to be determined by what we understand in general as being our average breakpoints for these different types of severities. So I'm going to make the first breakpoint value 251, so negative 251. And the next one's going to be negative 101. And then 99 and 269 and 439 and then 659, and the last one we'll go to 1300. We'll just leave it there as the max and click OK. So now we have our proper breakpoint values, and we'll want to change these labels as well. So change each of these to the labels that are shown in your lab handout. Enhanced growth high, enhanced growth low, unburned low severity, moderate low severity, moderate high severity, and high severity. And then I'm going to go ahead and click OK. So now this is reclassified. What this means is that we have more of a consistent understanding of what these classes are and what they might mean on the ground. And this is when we come to what the next step of the exercise is going to be, which is to take a different set of data, but using the information that we have created, or an image that has had the same process applied to it with different color values added, and actually making them more accurate for what was seen on the ground for the fire severity. So then we would be able to say if this is a high severity area, we would have an understanding of what that was, and it would be consistent across fires, not just unique to each individual fire. So your deliverable for this part of the exercise is going to be to create a map for this area. So you'll be going to the landscape view and adding your map elements. And if you want to get creative, you could use your Thimit tool and make up some information for a new incident so that you have access to the different map features, and try and apply that same kind of technology to this map so that it would come up with that pretty quality product. The name of this fire is the Selway fire, and I'm just gonna do 1, 2, 3, and 1, 2, 3, And let's see if I'll select a spatial reference. I'm going to import that. From one of these layers here. Click Add, and OK. And let's see if that'll work. Great, so now we can use that same procedure to use a template. And so we'll go for 8.5 by 11, and we'll do a graphic legend. Click OK. So we have a lot of different features here. You'll need to edit them. One thing I'd do is zoom in. So again, using the plus tool here, that's going to zoom into actually what you see on the map. And you'll also likely want to change all the features in your legend. You might need to add a different legend there. So anyway, play around with this and see, try out the different templates and see if there's other ones that fit better with what you're needing it for. Or if the templates aren't really working, then you can just manually enter the pieces that you need. So save that, and so export it as a JPEG and enter that into one of the questions in your lab questions for Lab 7. And then the next part of this exercise is going to be quite a bit longer. It's going to be a tutorial that was given by the Remote Sensing Application Center, and it involves taking a rough bark map, so something similar to this except with colors applied to it, and then using ground truth points, making different thresholds for what is low to high, different severity classes. So make sure to follow the directions carefully. The document that has the directions is on BB Learn, as well as the video tutorial for that.